In the first part of this lesson, we learn what inverse functions are and how they behave, and a few concepts about inverse functions. But now is the turn to learn how do we actually get the inverse of a function. And the process, even though sometimes it might be long, is the same process. It's a mechanical process. We just have to follow a few steps. And the first step is we need to replace the function notation for the variable y. So in this case, we're going to replace this f of x for a y. That's it. That's step one. Then step two is we have to interchange the x and y of their current positions. So we have x and y here. We're just going to grab them and interchange their position. And it works with any function, even if it looks like a harder function, harder and longer function. It's always this. We replace the x and y of position. And now, step 3, we solve for y. Now, this step is going to change depending on the function that we have. But for this function, this is a two-step linear equation. We learned it in lesson 3.2. So, we know we have to start with the -1. The inverse operation, or the opposite of a -1, is a positive one. So we can cancel them. But what we do on one side of the equation, we have to do it on the other. X plus 1 is simply x plus 1. Now we have 2y. 2y is a multiplication. So the inverse operation of a multiplication is a division. So we divide by 2. That way we can cancel the 2 multiplying the y. But if we do it on one side, we also have to do it on the other. X plus 1 divided by 2 is just x plus 1 divided by 2. So that's it. We solve for y. That y is fully isolated. That's it. We finished step 3. We solve for y. And as said before, this step 3 might be different for different functions, different equations, because we have to follow different steps depending on the equation we have. But the idea is the same. We have to solve for y. We have to isolate that y. Then the final step, step 4, is we replace the variable y for the notation f inverse of x. Remember, the -1 means f inverse of x. But we generally don't write equations like this. We write the function notation first. So let's just change it. F inverse of x equals x plus 1 over 2. So this is the inverse function of the original function we had at the beginning of the problem. And that's it. This is how we find the inverse of a function. But how could we be so sure that what we have is the inverse of a function? Let's analyze that. Let's test it. Here we have the f of x, the 2x minus 1, the f of x we started with. And here is the f inverse of x that we just calculated, x plus 1 divided by 2. In order to test them, that they are inverses, we're going to make a composite function of them. That means making f of f inverse of x. Or we can write it like this because it's easier to see that f of x is the bigger function, so we start with f of x. And then f inverse of x is the smaller function. It's inside of f of x. So we need to replace that x of f of x for f inverse of x, which in this case is x plus 1 divided by 2. All we did was replace the x for that new inverse of the function. And this is the inverse function. But now we have to simplify this. We cannot finish this problem unless we simplify it. And the reason we have to simplify it is because we have to make sure that they cancel each other. The first step we can do here to simplify is we have a 2 multiplying outside of the parenthesis and a 2 in the entire denominator inside of that parenthesis, meaning they cancel each other. And then we have plus 1 minus 1, they also cancel each other, leaving us with just x. So f of f inverse of x equals x. And remember, the inverse function must cancel the original function, so the fact that we're getting an x is a good sign. It means, yes, this is an inverse. Because when you cancel them, you only get left with the input. And what was the input? X. If we use another letter, we're supposed to get that letter. If we use a number, we're supposed to get that number at the end. Because inverse function cancels the original function. But this process must work both ways. So we first did f of f inverse of x. Now we do f inverse of f of x. So we can see it better like this. F inverse of x is the bigger function, so let's write it. X plus 1 over 2. And f of x is the smaller function that we're going to replace for the x. So 2x minus 1 goes there for the x. And then we have to simplify it, because if we get x, it means yes, they are inverses. First thing we do, this parenthesis, there is technically a positive 1 multiplied outside of the parenthesis. When there is nothing in front of the parenthesis, and with in front I mean to the left of the parenthesis, it means a positive 1. And positive 1s really don't make a difference. So what we can do is simply not write the parenthesis in the next step. Then minus 1 plus 1, they cancel each other. We're left with 2x over 2, but we run out of space, so let's bring it up. And then 2 divided by 2, they cancel each other, leaving us with just x. So f inverse of f of x equals x. And since the original function must cancel the inverse function, it means yes, they are inverse. So these are the steps we follow to get the inverse of a function, and then the steps we follow to check that the inverse function is actually the inverse function.